Brilliant. So hi everyone and welcome to Makers Demo Day. My name is Anastasia and I'm the client partner admin here at Makers. As you know, we are Makers and our mission is to transform lives and organizations by bridging the gap between industry needs and underdiscovered talent. And so a little bit more about our Makers. They are a dedicated group who are passionate about tech, continuously growing their skills in both development and collaboration. They've gained essential technical skills, improved problem solving, and continuously expanded their capabilities. And they've been undergoing a bootcamp journey. And during this time, they've built strong foundations before diving into their chosen specialism and applying their knowledge to real world projects. In terms of collaboration and innovation, through teamwork, they've honed their ability to communicate, innovate, and drive projects forward. So some housekeeping for today. We ask that you please stay muted for the duration of today's presentations. They typically last around 10 minutes for each team, and guests who wish to learn more about Makers will find information in a follow-up email along with a recording. And now I'll pass over to Leo.
Hey, thanks. Hopefully everyone can hear me fine. Hi everyone, thanks for joining this data engineering demo day today. So I'm Leo, one of the technical coaches here at Makers. And I'm just going to say a few words to introduce the cohort before we move on to the presentation themselves. So some of you will already know this, but for context, these learners who are about to present to us today are at the endpoint of their 12 weeks of the immersive data engineering program. So if you're an engineer yourself, or if you're in a technical role or in a technical organization, you'll probably already be conscious of this, but in today's tech landscape, data engineering is a big and essential piece of any software team and software system. And today, organizations, whether they're small, medium, or really big, do rely on increasingly large numbers of data to power the services, the applications, and to bring useful business insights to stakeholders. And so there's, again, an increasing number of challenges that come to this in having the right infrastructure, the right tools, the right technologies, the right software to not only move this data across different places, different databases, but also process it efficiently, make sure that it's used in the right way, in a way that is secure, that's efficient as well. And that's precisely what these students have learned in this last few months to become data engineers who can go in organizations and help with all of these challenges. So for them, that involved learning quite a large number of tools or technologies or concepts, from Python to relational databases, to SQL performance, to using pandas to explore data sets, to workflow orchestration tools such as Airflow, stream processing technologies such as Kafka, cloud platforms, so mainly AWS with EC2, RDS, MSK, but also monitoring tools like Prometheus and Grafana, scaling strategies, an awareness to security and how to do vulnerability scanning, and also how AI fits into this landscape. And all of these sort of came together in this last project on which they worked only for almost less than a week, but it was very condensed. And so as they were learning all of these technical skills and concepts, they also kind of worked in teams or pairs most of the time. And so they also had to sort of learn more teamwork, giving and receiving feedback, communicating, all of these things that we refer more often to soft skills, even though they're as important. And speaking from my experience as an engineer myself working in teams, I can say that these skills kind of make the difference in software engineering, which is like a very complex discipline. And so they've learned all of that as well. And all of that in 12 weeks. So that feels like a lot when I say it. And that's very, if it sounds challenging to you, that's because it is, because all of this is in just like 3 months. So before we move on to the presentation, I just want to pause a second so we can all appreciate the work they've put into learning all of this for these last 12 weeks, and just give them a round of virtual applause as of now, because as I was saying to them earlier, most of the hard work is already behind them. They will likely talk more about it themselves. So I'm going to stop speaking in a minute, but just a bit of context of what they worked on in this last week. So they were given a large data set, sort of scattered, spread across different databases on AWS RDS on the cloud, and they had to implement an infrastructure to power a business intelligence dashboard with some charts to present useful statistics and insight from this kind of like raw data set that they had to explore. So that involved a bit of work of doing some data exploration, some coding, some design, planning, and implementation of a cloud solution, all in teams. And all of this again in less than 5 days. So again, that speaks volume to the challenge and the amount of work that they have put into that in the last days. But I'll now stop speaking and I'll just kind of give the mic to the teams, and they will do a better job than me at explaining exactly what they did and the challenges they faced. So the first team to present today is Team Emerald. Are you ready to go on? I see not. Yes, great. So I'll mute myself and give the hand to them.
Okay. Hi, everyone. So we are Team Emerald, and this is our presentation on the data visualization for the program of International Student Assessment.
Hi, I'm Jess.
I'm Sam.
And I'm Matt.
So, the PISA study was conducted by the Organization for Economic Cooperation and Development. It's designed to assess and compare educational systems worldwide by measuring school pupils' performance. Policymakers at both national and international levels increasingly rely on insights from assessments like PISA to shape educational strategies and decisions. This data set was substantial. It covered thousands of students' responses across 20 countries, with each response containing around 1,000 individual data points. So our role was to work with this complex data set and create an ETL pipeline to transform it into a real-time, user-friendly dashboard. So this is a snip of the data set we started with, and this is our dashboard at the end.
So as Leo mentioned, this is basically taking all the skills that we've learned over the last sort of 12 weeks and the range of technologies, how we wanted to integrate them into the pipeline that we've created here. So it wasn't so much about necessarily just getting the sort of answer in the quickest way. We actually wanted to create something that was utilizing and exploring all of the tools that we used. So we spent the first sort of day or so coming up with the plan that you see here. So on the left, we have basically the sort of rough setup. So this was what was provided for us, which was that the database was providing, as Jess mentioned, over 1,000 columns of data. We would then push that into a local, much smaller, scaled down version where we do those analysis and transformations. And from there, we would then push those to the dashboard. And that's the sort of technical approach that we took. And now in terms of more of the sort of soft skills, this was as much of a working as a team to get those results as it was actually the technical side of things. So each day we had very clear end of day goals. So here we would set, relatively sort of small but achievable goals for what we wanted to do. We would then use those to break down those into tasks, working together when it was necessary, splitting off when it was sort of the best use of our time. And it allowed us actually to make sure that we were on track. It made sure that we were all using our sort of skills to the best of the ability. We weren't wasting sort of individual skills when we were best split off. And yeah, that's the approach we took for the 3 days. It was very sort of carefully mapped and closely mapped, and we followed it pretty well, actually. So we got everything covered in time. Yeah.
And then so part of that process was also having like considerations for how we planned it. So for example, we wanted to make sure that we were implementing something that was observable, so like repeated in that sense. evaluating resource split between API endpoints and data extraction. So making sure that we had one EC2 instance for our Airflow and then one for our API as well. So at least if there was multiple points of failure, so at least that if something failed, that we could pinpoint it a bit easier. We decided to go with Fast API over Flask. So when we chose our API, because for simplicity and performance. And then also we decided that the way that we sort of structured everything was with a scalability in mind, and just in the sense that we knew that it was never going to be massive or anything, but just in that sense that like having the skills and the experience to try and make something that way. So then also the challenges that we faced essentially, if I just put all these up here, so it was like observability versus latency. So like when we introduced sort of monitoring, it gave us some delays, but then of course like this helped ensure reliability. If there was anything that was going wrong, then we could find out where it was. Unknown schema, so like limited visibility into wider data structure and required assumptions. So we needed to, I think in terms of like the front end, for example, it was just doing a bit more research into how the endpoints were being pulled, like specifically with, for example, with the submissions over time. And then overhead complexity. So using tools like Airflow, basically, yeah, as with any sort of project, introducing a bunch of different things, setting it all up. That gave us some issues at the beginning, which, reduced our time. And then, so task granularity decisions, deciding how to break up these tasks, making sure we just used our time input for the things that needed those things the most. And now we'll talk about some optimizations.
So yeah, it was as much of an exploration of things that we could do better. Every time that a decision was made, we explored the sort of trade-offs that was taken, and this is just a sort of small handful of things that we could have done. So we could reduce stored data. So the actual dashboard that you saw, there's only sort of 5 or 6 actual data points that are needed, whereas what we're keeping is a lot more data. So that would allow for sort of future analysis. But if there was no future scope or there was no expansion needed, we could skim down what we're keeping in our local database, which would allow us to speed up that process, certainly make the whole thing a lot faster and a lot more lightweight.
Another thing we sort of thought about was with Airflow parallelism, which is hard to say, but essentially like the tasks were running sequentially, but it probably would be better if we could get them to run concurrently, maybe using a different software perhaps or something like that. And then
another way we thought was by trimming the layers within our architecture. So consolidating some of our ETL steps, which would result in a faster pipeline with fewer dependencies and lower latency.
And that's us. If there's any questions, we can do our best to answer. But that's us.
Great, thanks. Well done, team. Is there any questions from the audience for this team? Technical or less technical? Maybe I'll monitor the chat if there's any questions coming in.
what was the most frustrating moment in this project?
I think the most frustrating part that we had was actually, it was not the complex stuff, because you expect the complex stuff to be complex. It was more the simple things like getting everything talking to one another. A lot of stuff that it should work and I don't know why it doesn't. Those are the sort of main things. The stress points that you're not expecting always hit you a lot harder than this is going to be very hard and take a long time. That was sort of our rough experience, and there was plenty of those.
Thanks, Bex. It just says, how did you overcome those stressful moments? Lots of communication, really, main thing, right? Just sort of talking through things, thinking, but also like being very easy to listen to, I suppose, in the sense that, you know, like every time there was an idea, or if we did have any sort of conflicts, we did look into like each person's idea though. So yeah.
And how did we decide to use EC2? It was because of the flexibility that was offered. You know, we wanted to explore this, even though it was in a simulation, think of it as a representative of the real world, so that with an EC2 instance, it enables us to scale a lot easier. It enables us to add sort of more functionality and tools in a bit of a less strict way than something like a Lambda would. So that's why we went with the EC2.
Oh, okay. That's fair. Were you surprised? Were you surprised by how much you could get done in just a few days during the final project after going through the training? Yeah, I think so. Yeah, definitely. I think it was like there was a. I think that now looking back, it's kind of crazy that it's Thursday and we kind of got it. I mean, where it is, in some respects. Yeah, I don't know. We all sort of we know it. I think I mentioned as well, like being. It's like the difference now. I think understanding like what it is to be a junior now is that we know we can do all of these things. We just the junior part of our experience is that we don't know how long it will take. So these experiences are really good because it sort of gives us that like experience in my point of view in that respect is knowing how to basically time mark a task. You know, like a senior will be able to tell you like that will take me a day or 2 days or a week. But I think at our stage we know we can do it, but it's just whether or not it like how long it takes. So doing something like this is helps to essentially get more understanding of that.
Nice. Thanks a lot for your answers and for whoever asked questions. So if there's any more questions for this team, just for the sake of time, maybe keep writing them in the chat, and I guess the team can sort of write any answers directly in the chat as well. But now let's move on to the second team presenting today, which is Team Sapphire. Are you ready to present?
I think so. Thank you.
Great. I will mute myself.
If you could possibly share your screen, Leo, that'd be fab. Thank you. Wonderful. So hi, everyone. Thank you so much for joining. I'm Ollie, and I'm part of Team Sapphire, and I'm really excited to be presenting along with my colleagues from Sapphire, Edith, Edgar, and Dylan, on our final project as part of the data engineering pipeline on the brain course. If we could go to the first slide, please, Leo. So the problem statement that we're dealing with, you might be quite familiar with it by this point, but Global Education Insights is a non-profit working to improve education systems worldwide. They'd acquired the PISA 2018 dataset, which holds a large amount of student performance data across multiple countries. While this data could uncover insights that help Global Education Insights influence policy and practice, it's too large and it's too unwieldy in its current form for the team to be able to get meaningful insights from it. So for this project, our task was to build a real-time dashboard that could take this incoming data, process it in the cloud, and feed clear, up-to-date metrics like average scores or student learning hours per country, that sort of thing, into a data visualization tool called Forage. Our challenge was to keep these metrics as fresh as possible, ranging from hourly to minute by minute, or even up to the second updates. That would mean wrangling messy and sometimes incomplete data and deciding on the best approach, like batch ETL or streaming, to deliver near real-time insights. And by doing so, we would empower GEI to make data-driven decisions that could improve education systems around the world. If we could move to the next slide. Thank you. So our first step as a team was to ensure that we collectively understood the problem space and the scope of our work. So we started by drawing out a very rough diagram of the data flow to confirm what we needed to do as a team. So firstly, the source data is hosted on an Amazon relational database database with separate country-specific databases. Each database is updated independently before we as a team ever see that data. So our task is to extract that segmented data, combine and clean it, and then transform it. So calculating metrics like total record counts, average socioeconomic scores, or average studying hours. And then finally, we would load that transformed data into a format consumable by the Forage dashboarding tool. And just for anyone less familiar with the term ETL, it stands for extract, transform, load. So you extract data, transform it, load it somewhere else. And that's a standard process in a data engineering pipeline for moving and refining data between different systems. So during planning, we considered a few different solutions or ways to solve this. The first was a traditional ETL pipeline with an analytical database. We could have created an additional database, for example, another RDS instance to store all of our query results. The Forage dashboard or an API that we build could then query this centralized analytical database. This approach is very scalable if we anticipate huge volumes of data or complex feature analyses, because having a dedicated database makes queries faster and easier to manage over time. Our second kind of potential route was real-time streaming. So for truly real-time data, where we want sub-second updates and need to handle very high throughput, we also considered a streaming architecture. We would likely set up an Amazon MSK, so a managed Kafka cluster, to handle data ingestion and processing. However, while prototyping our MVP, we noticed that new data was already being processed in under a second. So by simply storing our aggregated results as JSON files on the same EC2 instance that runs our Python scripts, we kept this process near real time with minimal overhead. Given our SQL queries were fairly straightforward, they were mostly aggregations like average scores or counts, a full analytical database felt like it would add unnecessary latency, cost, and complexity without delivering a clear benefit for our immediate needs for GEI. So ultimately, we decided to keep things quite lightweight and simple by writing out aggregated results to JSON files on the same EC2 instance running our Python scripts. Specifically, we perform in-memory transformations, so combining, cleaning, and aggregating data directly within our application. Then we immediately write the final results to JSON, all within the same environment. Here are the reasons we went for this. So firstly, performance. We observed that combining and aggregating data in memory, then writing the results to JSON, took less than a second in our tests. This could be made even faster, of course, but we're aware that having a remote database hosted on its own cloud instance and having data transmitted to it over a network would add latency in itself. So all things considered, combining and aggregating data in memory and then writing the results to JSON meets our near real-time requirements effectively. Secondly, we consider reduced complexity and cost. So setting up and maintaining and scaling a separate analytical database would involve additional cloud expenses and introduce more moving parts to manage going forward. This might be a worthy trade-off if the data or business needs grow more complex in future, but our simpler JSON-based approach avoids that overhead for now. Thirdly, it directly integrates with Forage. So the Forage dashboard expects to consume data in JSON format. By storing the output directly in JSON, we avoided extra serialization and deserialization steps. And so the dashboard can either read these local files or we can easily serve them via a basic HTTP endpoint. And finally, we went with this because of its flexibility for future optimization. So should our requirements change, for instance, if we need more advanced analytics or historical data at scale, we can refactor this approach really easily. For example, we could then integrate a dedicated analytical database on AWS without losing the core logic that we've already built. So in summary, here is a brief outline of our workflow: extraction, transformation, output to JSON, and then dashboard consumption. And by focusing on clarity, cost effectiveness, and maintainability, this approach delivers the required metrics with sub-second latency. It integrates easily with Forage. It keeps our running costs and our complexity to a minimum, and it remains flexible if we decide to scale it up in the future. So with all of that said, I'd love to hand over to Edgar, who's going to share a bit more about our implementation of this.
Hi everyone. So I'll start talking about the first real challenge that we faced, which was pulling data from 20 different databases all at once or as close to that as possible. To handle this, we built a function that uses a loop to iterate through a list of countries. Good news was that all the databases share the same user credential and the same schema, so setting up the connection was quite simple. Inside the loop, we run a specific SQL queries on each database, just enough to extract only the data that we actually needed. That help us to keep the process efficient, less data to move around, faster queries, and a clean result from the start. Right after the pulling the data, we formatted on the fly, so it was ready to go straight into our dashboards, which meant we saved time on later transformations, and all the results were stored as a list of dictionaries inside the function. And once the loop was finished, the structured data was writing out as JSON files and upload directly to an S3 bucket on AWS. In the end, we had a clean, efficient pipeline from database to dashboard, and everything was handled in a way that was maintainable and easy to monitor. So in the next slide, you can see just a piece of the function that I was talking about. And we go to the next slide. So at the start, our MVP involved storing JSON files locally. It was a quick and simple way to test our data pipeline and get a working proof of concept. Once we confirmed that everything was functioning as expected, we moved on to the next step, was integrating AWS S3. By switching to S3, we gain key benefits like persistent and redundant storage, virtually unlimited space, and protection from any local machine issues or failures. As you can see in the first screenshot, we have our JSON file saved locally, and the one under, you can see the same files stored in our S3 bucket. If we go to the next slide. Yeah. So one of the main challenges in making this switch was basically setting up the right IAM role for our EC2 instance. This role needed permissions to read from and write to the S3 bucket, and at the same time access to AWS Secrets Manager, where we securely store sensitive data like the username and the password of the databases. This setup ensured that our application could securely talk to AWS services without hard-coding any credentials. And then came the code change. Locally, the file input-output was simple. We could just open a file, read it, or write directly into it. But with S3, we had to handle things slightly different. We needed to encode the data when saving and decoding when loading it. To make this process smooth and maintainable, we created clean, reusable function for each key operation, which was reading, writing, or just checking the file existence. These helper functions made our code much more readable, elegant, and modular. You got an example of this function in the next slide. Yeah, so that would be all for me, and I will pass it to Edith.
Thank you, Edgar. So some other technical deep dives we've explored during this project are secure secrets management. So to handle credentials securely, we integrated with AWS Secrets Manager, and rather than hard coding usernames and passwords, our script pulls them dynamically at runtime. To keep our data pipeline running continuously, we deploy the script on an EC2 instance. We use systemctl to turn the script into a service. That means it starts on boot, restarts automatically if it crashes, and logs its output to the system journal. This taught us how to create reliable self-healing infrastructure. And another technical deep dive that we did is robust error handling. And thanks to this, we made the pipeline resilient. If one country's database is down or a query fails, we log it and move on. This prevents the whole pipeline from crashing and ensures we still get partial data where possible. It's a simple form of fault tolerance that really makes a difference in production. If you can go to the next slide, Leo, please. Throughout this project, we learned a lot about what it takes to build a data pipeline that's both reliable and production ready. We started by connecting to multiple databases stored in an RDS, each one representing a different country's data. That gave us experience querying across several logically separated datasets and aggregating metrics like submissions, learning hours, and socioeconomic scores. From there, we built out an automation layer, running our scripts continuously on an EC2 instance using systemctl, which helped us keep services running 24/7 without manual intervention. We also moved away from storing data locally, like Edgar said, and began writing all our outputs to an S3 bucket, which really pushed us to think about durability and cloud-native architecture. Secrets management with AWS was another key learning. Using Secrets Manager meant we could handle credentials securely without hard coding anything. Serving the data through Fast API taught us how to build clean, structured endpoints that are ready for front-end consumption, and we learned to shape our data specifically for visualizations, so everything integrates smoothly on the front-end side. And finally, we saw firsthand how important logging and error handling are, especially when dealing with multiple sources, variable data quality, and a live running system. Overall, it was a great deep dive into data engineering, DevOps, and building something that feels like a real-world system. And now I'd like to hand over to Dylan.
Thank you. So on the screen is a screenshot of our dashboard and the 5 charts being updated in real time. The top left one may look a little funky because we've got some negative sort of values that come in, and yeah, we didn't have full control, so we had to leave it like this. But it's where we were at probably a day or so ago before a large influx of data. And next slide, please, Leo. Thank you. And as the team have mentioned, because we opted for quite a lightweight and effective solution, we had some time at the end to think about how we would move from this MVP to a more production-ready product, I guess. And with our while loop script, just a plain vanilla Python script, it's giving us near real-time data, but that would really slow down as things increase. So as the volume of data increases, as business logic and queries we make become more complex, we would struggle to maintain that low latency. And so the next step in our project would have been ideally some sort of streaming solution. And as Oli mentioned at the beginning, during the course, we've looked at Kafka and AWS MSK, the managed streaming for Kafka. But because of not having so much time at the end to prototype, we actually prototyped with something new, and that was using AWS DMS, so their database migration service, and Amazon Kinesis, which is their streaming service. And in short, we managed to prototype this for about 5 countries of the 20, just to see if it was working. And the database migration service is sort of tracking and replicating the 21 databases with our country's data. And so it uses something called CDC, so change data capture. Anytime new data or records get entered into our source databases, our DMS instance is going to capture those changes and push them into our Kinesis stream. And so this gives us the real-time stretch goal that we were trying to reach. And then once we have that stream, we can then transform our current Python script, which is polling 21 databases every second, which is quite a high workload for all of our services. And we'd switch that up to a Python consumer just to consume from the stream as events or records are being added. The bottom part of the screen is looking at developing our build automation. So Edgar really nicely added all of the system services for us, which gives our script, makes our API and our script to run on boot, retry and failure. And that gave us the automation we needed for this MVP. But if we had some time, we would add perhaps some infrastructure as code, perhaps Terraform, to help us spin up this infrastructure with ease and give us the ability to version control and maintain consistency. We added some small amount of testing, and again, we'd try and expand that into a expansive test suite with running in pipelines and automated testing. And then to the right is the monitoring side, which we really would have liked to do. So if we had the time, we would have run the Grafana and Prometheus stack for our system health and our system metrics. And then we would have most likely have used just the basic CloudWatch logs to manage the logs from our actual Python scripts. That's all from us. Thank you very much for listening.
Great. Thanks, team. Well done again. Is there any question for this second team? Just going to wait a bit to see if there's any question up in the chat. This is one. Did you have trouble setting the right access permissions for the S3 bucket?
It meant learning on the fly how to work with IAM roles in AWS. I think that some of us had come across that a little bit more before than others. I, for one, hadn't seen a lot of how to configure those. But it was a really good learning curve, being able to go in and like define new roles, assign them, set specific permissions. And yeah, I learned a lot from doing that. For the question on what file type to be used for storage in S3, I believe we kept it in JSON files. The reason we did that really is because the format that the API endpoints were expecting was JSON, so it was just cleaner to save it in the format that it was going to be served in. So it kind of made logical sense for us. Anyone want to jump in for any other questions?
There's two more things. Looking about how you work together and individually, what's one thing you do differently if you were starting over? Don't know who wants to jump on that one.
You going, Edith?
I don't mind taking that one, yeah. Maybe if we were to do this again, we'd add a bit more structure. Like it was really nice to work all together, but I feel like we're all on the screen and trying to do everything rather than separating the tasks. And I feel like for a future project, that might be a better way. But we did enjoy it.
Agreed. I think we took mob programming quite literally. We enjoy working together, and we enjoy the kind of collaborative vibe of being kind of working through stuff as a team and solving it. I think maybe for a longer term project, or maybe for a team that was bigger, that maybe would make so much sense. So we need to break off into maybe smaller sub teams. But I know we had a good time. So for this project, it was I thought it was a good trade-off to make. What did we enjoy the most? Question. I enjoyed this. I mean, silly one perhaps, but I enjoyed the satisfaction of like seeing how quickly our pipeline could actually work. That feels kind of maybe like a no-brainer or a silly one, because we are talking about like real-time updates, but the fact that we could see the success of our output happen so quickly in real time, and it would just keep happening once we'd set it up as a system service. I mean, I got a bit of a buzz out of that. Yeah, aside from that, I enjoyed getting exposure to like a wide range of different AWS services. Obviously, for our MVP, we kept things relatively simple, but as Dylan mentioned, and as Edgar mentioned as well, like we then dabbled in like using S3. Then we were looking at different AWS services to like augment and scale our work a little bit more towards the end, and that was really interesting.
Definitely. And there's a question around how we tackled some of the implementation decisions. I think the key there was we just started super simple. So we all knew Python. We didn't all know Fast API, but our Fast API file was like 50 lines. Our Python script to get the MVP running was, I think, just over 250 lines. So it wasn't a huge amount of code. And this let us get to see that sort of screenshot with the dashboards populated within sort of a day or two. And then we had the freedom to try new things. So look at what would streaming look like. Don't try and do it all because it's not going to happen, but just do it with like 5 databases and see it work. Think about starting some automation. Edgar started with all of the system services, but maybe not try and do a whole Terraform configuration. And so I think that gave us no like sort of issues running into time as we move through the project.
Right, thanks a lot for your answers, and thanks everyone for your questions. I was about to say there's the last one, but that's not the question. So good. Thanks, Jose, for that one on the behalf of the team. And I guess that's a wrap. Thanks everyone for joining this demo day today. Just a few words to close in. Well, thanks for to both teams again for the amazing work they've done. So again, a round of applause, virtual or real applause and appreciations to them. And I guess what I wanted to say is I've worked quite a few weeks on the past few months on this course along with a few other coaches, and so it was really good, really I mean, I really enjoyed like seeing their growth on these different skills and technologies as they were learning and as they were working together. And I guess as a coach, what I can say from my experience at Makers, that there's always a kind of the curriculum and what students go through and what they learn and what you essentially what the challenges that you put them through so they can learn all of these things. But then there's also for each group and for each set of students how they react to it and how they, in a good way, obviously, but how they bond and how they create this cohort culture, which I guess is what happens in any organizations, small or large. And I can say that for this one, I really enjoy seeing that cohort culture being brought to life as well. And they started like very strong support culture in face of the challenges and kind of helping each other and discussing with each other and also organizing line-in talks and on different topics to learn from each other on things that were kind of extracurricular as well. And yeah, that was just like really great to see. So yeah, definitely going to miss working with that cohort. And I know that there's a few people from employers here, probably future colleagues or managers, and you're going to be lucky to work with these people. So yeah, we have this saying at Makers that we used to say, once a maker, always a baker. So yeah, hopefully we'll keep in touch, and I'll be in touch with some of you on the next steps of your journey. And yeah, thanks everyone, and yeah, thanks again for attending today, and have a great rest of your day.
Thank you, guys. See ya.
Thanks. Great to see you.
Bye, everyone.